Alright, so welcome back again. This time what we're going to do is we're going to just get a little bit more into the debugger. We're also going to put a program on here that's a little bit more interesting than what we've done so far. So go ahead and open up MPLAB again. If you really want, you could create a new program, but I see no reason to do that. You could continue with what we were doing last time. You can go ahead and make sure that you can hit the debug and it shows up and everything's happy. But hopefully you've got that from last time still running. What we want to do here is we want to add a little bit more code just so that we can play and do a few more interesting things. So let's go ahead and add this code. Delay 10K TCYX. So what does this do? So first, it looks like it has a syntax error. That's because delay 10K TCYX, it may be a lowercase k or an uppercase k, I'm not sure, but either way, it's a function we didn't write, so we need to include it. And the function, the place where this function lives is in a file called delays.h. The way you know about which magic library it's in is from the courseware website. So the courseware website, we have a file in here that you may as well save. It's handy. It's a PDF that talks about the libraries. So let's see if I can find out where it's at. So it's the not the diagram, but the C library files for MPLAB. Inside of here is a lot of useful information. So if you look inside here for delays.h, once it finishes loading, you can see that it's a file that we can use and include, and we'll talk about this in class as well, but it's got a lot of functions that you can use. One of them is called delays. So if we scan in here for the word delays, we could find it in various places, and we could find a function called delay 10K TCYX. And so this is, I finally found the main section. There are a lot of delay functions. If you open this, by the way, not inside Chrome, but if you actually save it and open it up inside Adobe Acrobat, there's actually a table of contents to make things easier to find. But delay 10K, what it does is it delays for 10,000 instruction cycles. And the way you use it is quite simply pass in a parameter and it'll delay for that many instruction cycles. So we pass in 100. What it'll do is a delay for 10,000 times 100, which is 1 million. The way we've set up the clock is it's how many microseconds, so that's 1 second. All right, a lot of talk there for very little action. And then what we'd like to do here is we'd like to change port C some, and let's just put in something for port C that I think will look interesting, and it's 3 zeros, 2 ones, 3 zeros. Oh, by the way, I figured out how I could change my font, so I'm using a different font this time. And so what we want to do is we want to simply add a change to port C and then delay. So I've kind of got the order wrong here. So make a change to port C and then delay. And then what we're going to do here is we're going to make a change to port C and then delay. So what this is going to do is it's going to do it once because it's in the area that happens once. But if I wanted to move it down to the area that happens forever and hit Alt-Shift-F, you can see it'll do the 2 LEDs and then it'll do 4, and it'll just go back and forth forever doing that. So the goal is not to learn the programming, the goal is to make sure you can upload it. So now we've got something that will change. So it's programming my target, so now it's got 2 and then 4, 2 and then 4. So pretty simple. Things we could do to make this code better is instead of typing 100, let's say we wanted to change it later to 50. Then we'd have to change it everywhere. So what you do is instead of including a magic number, you make a constant. I'll call it delay time. So I'm using it, but now I better go define it. I like to define all my constants near the top. So I say pound define. delay time, and I'm going to make it, I'll tell you what, instead of 100, I'll make it 50. Note that there's no semicolon. So now what I'm going to do is I'm going to add a few more. I'm going to put it back up into the area that happens once. And I'm going to go ahead and make it expand kind of from the middle out until it's all the way full. So I'm going to do to where there are 2 LEDs on, then 4, and then 6, and then 8. And this is going to kind of grow from the bottom what it's going to look like. And then in the area that happens forever, what I'm going to do is, and these are random choices, I'm going to make either the first one on or the last one on, and I'm going to toggle back and forth between those forever. So you can see that this one has just the bottom LED on, and this one has just the top. So that's RC0 or RC7. So if I run it with this guy, what that's going to do is it's going to kind of start from the bottom once it's finished programming. And it's going to do the 2, then the 4, then the 6, and then the 8. And then in the loop forever, it's going to just toggle back and forth. So now we've got kind of a slightly more interesting program. I'm going to stop it from running. And I'm going to set a couple breakpoints. First, I'll set a breakpoint on line 60. And then on, well, what's my line 64, you set a breakpoint just by clicking on the number in the gutter, is what it's called. So whenever it hits this line of code, it's going to pause. So if I run it again, it'll do the same thing it always does. So it'll build it, load it, program it, and then it's going to start running. You can see that it's running and it hit this line. So right now it's got 2 on, because it's paused before it turns on 4. If I wanted to, I could click the step over button. So now it stepped over that function down 1. So now it's got 4 lights on, which is kind of neat. I'm going to hit play so that it just falls through to my next breakpoint. So it hit this breakpoint. Sometimes you'll notice that it kind of jumps past your breakpoints. There it jumped past my breakpoint by 1. That's a little glitch, but you better make sure you're able to deal with it. So here it actually did stop. But it actually executed that line, which is not what I wanted, but life will go on. And then if I hit play, it'll drop into the area that loops forever. If I wanted to set a breakpoint, I do have to pause it before I can set a breakpoint. So if I set a breakpoint on line 69, it says there's too many breakpoints active. No big deal, I'll take off some of the other ones. And so now it's going to hit this, and if I hit play, it'll do 1 lap, and then hit my breakpoint, hit play, do 1 lap, hit my breakpoint. Should be pretty easy. The other thing I'll mention today is that it also shows you some variables. So whenever you hit pause, it'll update and show what the variables are. So right now it's set to that. If I set another breakpoint and hit play, you can see that the value changed to a different number. You can display it in variables. You can display it in binary if you'd want. I just right-clicked next to the word value. I just right-clicked right there, and then it let me display it in a different way if I wanted. NetBeans is nice. It lets you like resize windows and stuff. So the idea of the debugger is that it's really handy to set breakpoints, so you can clear them off just by clicking them again and let it run. It's a really great way to figure out what's happening inside your code. The one downside of the debugger is, let's say you hit, let's say you unplug this thing, then it just sits dead, right? Like you can't use it. So the nice thing about the debugger is that you can figure out what's going on inside your code. The downside about it is you can't ship with this, right? Like you don't buy a fan that you have to plug a programmer up to. So if you wanted to ship it, you're going to need to program it in a different way, which we'll talk about in the next video lecture. So that was our quick introduction to using things as a debugger, which is this button right here, which is what you've been using most of the time. All right, next time we'll talk about the programmer.